Hello everyone. In this video, I will be discussing Learning Objective 3 of week 2. So far in Learning Objective 1 and Learning Objective 2, all the risk return models we discussed are one period models. So we actually discussed how to measure the performance of a portfolio over a single period time. In this learning objectives, we will examine risk and return over long investment period. So what we basically look at a multi-period model of risk and return. So to measure risk and return over a multi-period, a good starting point is to consider a quote by Harry Marquis back in 1996. What Harry Marquis said is, it's like a crapshoot in Las Vegas, except in Las Vegas, the odds are with the house. As for the market, the odds are with you, because on average, over the long run, the market has paid off. So what does this mean? Let's imagine that you are playing a coin toss game and there is no cost of playing the game. However, if the coin lands on head, you win $100, and if it lands on tail, you lose $100. So what's the expected value of this game? The expected value of this game is 0. Now, if you play the coin toss once, there is a chance that you get positive 100 or negative 100. It means that the actual return will be much more deviated from the expected return, that is 0. Now, think that you keep playing this coin toss game. So you keep tossing the coin. For each head, you continue to get $100, and for each tail, you continue to lose $100. And consistent with the law of large number, as you continue to play this coin toss game, your variability will be declined, variability will be reduced, and the actual return will be closer to expected return. So that's what Harry Marquis tried to say, that over the short term, although your actual return may be much more away from your expected return, however, over the long run, you actually get what you expected. Look at this example. This is a return from the rolling holding period in ASX index of Australia. So this is 1 year, 5 year, 10 year, 15 year, 20 year, and 25 year. So this is the best return per annum when you have a 1 year rolling holding period, and this is the worst return. So your best return was 86% and worst return was 26%, and in 58% times you had positive returns. So you understand that in 42% cases you had negative returns. However, on average, when you hold your stocks for 5 years, 5 years rolling holding period, your positive returns is 88 times. It means that 88% times you have positive returns and only 12% times you have negative returns. However, if you hold stocks for 10 years or more, look at the positive returns. 100% times you earn positive returns. It means if you hold stocks for 10 years, 15 years, 20 years, 25 years or more, in 100% cases, you will get positive returns. So that's the benefit of investing in long term. You actually subsume the short term fluctuation and you earn positive returns. So that's the normal phenomena of a stock market. Over the long run, the stock market provides more positive returns compared to negative returns. As a result, it provides net positive returns over a long period of time. Look at this another example. Now, consider an investor saving $1 towards retirement in 25 years, and expected return on this portfolio is 1% per month. Okay. Now expected terminal value, so it's 1.01, so 1% per month. So 300 months in 25 years. So expected terminal value is $19.79. Now, suppose the government bond offers a risk-free effective annual rate of 6%, so per month return will be 0.486755, and the terminal value will be $4.29. So you see that since this government bond offers you 0.48% per month, your monthly premium is 0.51 if you compare this investment and the investment in government bond. Now, what's the risk? Suppose that your investment for your retirement has these probabilities. There is 50% chance that each month it will generate positive 5.54%, and there's 50% chance that it will generate minus 3.54% on a monthly basis. So the expected return monthly is 1%. So 50% chance that it will generate 5.54% and 50% chance that it will generate negative 3.54%. So this is expected return 1%, and standard deviation is 6.42%. So that's a 1 month case. Now, after 1 month, if we extend it for 2 months, so there is 25% probability that the value of the investment will be 1.11, 50% probability that it will be 1.01, and 25% possibility that it will be 0.9305. So if you look at this binomial tree, you are investing $1. The best case is after 1 month, it will grow to 1.054 because you earn 5.54% positive return. And worst case is it will reduce to 0.9646% because you lost 3.54%. So this is after 1 month. 50% possibility that $1 will grow to this, and 50% possibility that $1 will reduce down to this. Now after next month, it's possible that you earn another 5.54%, so $1.055 grow to 1.1139%. However, it also might be possible that in the next month you actually lose 3.54%, so your investment reduced down to 1.01. Now, if you have lost in the first month, it's possible that in the next month you earn 5.54%, so it grows to 1.01%. And it's also possible that you lost in the first month, so it reduced to 0.96, and you lost in the second month as well, so it reduced to 0.9305. So there is 25% possibility that after 2 months, your $1 grows to 1.11, and 50% possibility that it will grow to 1.01, and 25% possibility that it will reduce down to 0.93. So you understand that after 2 months, still there's quite a high probability that you will lose your investment as your $1 reduced down to 0.93. Now, if you continue to consider this investment on a month-by-month basis up to 300 months, and there is a mathematical way, I'm not showing it at this moment, there is a mathematical way to calculate what's the probability that after 300 months, your $1 will be reduced down to less than $1. And if we calculate it, we will find that this probability is only 0.02%. So it's almost 0% probability that after 300 months, this $1 will be less than $1. So it's almost 100% chance that $1 will grow more than $1. So that's the benefit of investing in long term. So that's the end of our discussion on learning objective 3. Thank you.